For this lesson right here, this is just kind of a bonus lesson of just working with Venn diagrams and working with the symbols and the areas that they would represent. Obviously, these are going to be mostly played out when it comes to word problems and just sort of organizing the numbers and putting them where they should go and what they mean after they've been in the diagram, so that you can respond to some of those questions. So there's a worksheet we'll be doing in class, but I just wanted to give explanation as to each one of these 6 cases that you're seeing right here in this video. So starting with a couple easy ones. So the intersection of B and A would be the same thing if I switched the order and did A and B. That would mean the same thing. So I'll just write that here, but in either case I would get the same solution to either case. Key on intersections: when it comes to an intersection or the AND scenario, best understood that I can only shade the area that belongs to both sets. So it's got to be true about B, it's got to be true about A in order for me to shade it. So in this case, the intersection of A and B, or B and A, would be this area right here. So this is the intersection of A and B. Again, because it's an intersection, I can only shade it if it's true about both. It's got to belong to B and it's got to belong to A. And so that's where we would shade that area of the diagram. So when it comes to something like this, if we just said shade section A, everything that belongs to A, the reason I put this one in there is because oftentimes people will only shade this area here, and they want to leave out this because of the whole overlapping idea that it also belongs to B. Well, that doesn't matter. In this case, if it just says A, then I would shade everything that belongs to set A, which is in that circle. So this whole circle right here would get shaded. That's everything that belongs to set A. And so if you had numbers filled in, let's just say there were numbers here, 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 here. If they said, you know, how many items were in set A, then it would be this number plus this number are the items that belong to set A. Third case, B or not A. So most important thing you have to understand with a union, when it's a union, remember, this is one big happy set family. If it's a union, it's the union of this or this. So I can shade it if it belongs to either case. So for a union, if it belongs to B, I can shade it. If it's something that's not in A, I can shade it. So it only has to be true about one of them in order to get shaded. So if it belongs to set B, we can shade it. If it's something that is not in set A, I can shade it. So again, I'm shading everything that is true about either case. It does not have to be true about both. It only has to be true about one of them in order to get shaded. And so that's kind of the big difference with the unions versus the intersection. With a union, it only has to be true about one of them to get shaded. With the intersection, it's got to be true about both. Looking over here at number 4, so A or B not. So again, if you consider what is in A or B, well, let me lightly shade what would be true there. So this is the stuff that is in A or B. So those are the things that are in A or B. But this says the complement of that. So I want everything that is not in A or B. And so the answer that we would look for would be the stuff that's outside of those circles. So this is the area in red that we would want to shade. So this is the stuff that is not in A or in B. It would be that red area right there. So that's what we would want to shade, the complement. So that's a good way of looking at complements, is to do what this is saying first, and then basically identify everything but what you just looked at. Last 2 cases down here, looking at number 5. So this one says the union of not A or B. So remember, if it's a union, if it's true about either one, I can shade it. So if it's something that's not in A, I can shade it. So I'm going to start by just shading everything that's not in A. So that's everything that's not in A. If it's in B, I can shade it, because remember, in a union, it only has to be true about one of them in order for it to count. So if it's stuff that's in B, anything that's in B now qualifies as a winning part of our solution here. So again, it's a lot of times people want to leave this part out because they say, oh, well, it's stuff that's not in A. So, well, that's true. But remember, with a union, it only has to be true about one of them in order to get shaded. So if it's not in A, I shade it. If it's in B, I shade it. So that's what all that would belong to right there. Last case. So this is the stuff that is not in A and is not in B. So again, with the intersection, it must be true about both cases in order for it to be shaded. So I have to identify the area that is not in A. So obviously that's everything that is outside of circle A is not A. So I'm looking at all of this right now. What is the stuff that's not in B? Well, everything that's outside of circle B is not B. So I need to find the area that is true about both statements. So the stuff that is not in A and is not in B. And that would be the outside area that you see right here. So this is the stuff that is not in A. It's also the stuff that is not in B. So remember, because it's an intersection, it's got to be true about both statements in order for it to get shaded. So that is the stuff that is not in A and not in B. So one thing I want you to notice, if you look at cases 4 and 6, 4 and 6, we shaded the same area. The red here is the same as the blue here. They're both mean the same thing. It's two different ways of writing it, those two statements right there, but they both eventually mean the same thing, because you'll notice we shaded the same areas about both. And so there are different ways of wording word problems. There's different ways of giving you notation that might still refer to the same area of the diagram.